What's up, Science 8? Welcome to my crib. So this is Teddy. You can show him. Look over here, Ted. He's gonna look at me. And my mom came over to help me video, and her dog is Spike down here. Can you get him? Hey, Spiky. This is Spike. He's ferocious. So, and there's Teddy again. Okay, so you've already watched Investigation 2.1, and hopefully you did that. And so I'm going to go over just a couple of things that you may have missed from there. So remember our ammeter from 2.1. So this is the ammeter, and remember our range is 0 milliamperes to 500 milliamperes. And we needed to know how many milliamperes that each tick mark represents. So if you have 10 tick marks between 0 and 100, how much or how many milliamperes of current does just one small tick mark represent? So you say 10 of those little tick marks, and you take 100 and divide it by 10. Well, 100 divided by 10 is 10. So each little tick mark is 10 milliamperes. Okay, so we're going to start on the lesson 2.2. And so, no, they can't have the answers. So, some vocabulary you need to know. Well, I'll tell you the answers, but the vocabulary you need to know to get started is a variable, and a variable is any factor that could affect the result of the experiment. So we're going to have several factors in here, and or several variables in here, and we'll go over what the variables are, and then you need to know what a control is. A control is a variable that stays the same or it's kept constant. So let's read over the first introduction part. It says, in the previous investigation, you used an ammeter to record measurements in an electrical system. In this investigation, you will use an ammeter to study the relationship between batteries and current. So remember that batteries, so I've got my battery in here, so I've got chemicals in the battery. And what the battery does is it takes the chemicals and converts the chemicals into electrical energy. And then so what our battery then does is that electrical energy allows the electrons to flow through all of these wires as a current. So the current is created by the electrons that have been converted from chemicals to electrical energy by the battery. And that's number one. Number one says, how are batteries related to current in an electrical system? So if you need to stop and rewind and review that information that I just told you, you can, or hopefully you remember the answer to that question based on the vocabulary test that we did and the previous lessons. So going to number two, I've got some figures for you, and the vocabulary that we're going to introduce from this one is a series circuit and a parallel circuit. So you have two figures on your sheet, and again, you are following along on the EWIT Lab Investigation 2.2 and answering the questions. But number two says batteries can be connected to an electrical system in one of two ways, in a series or in a parallel. So the first figure you have there is showing the series. And a series takes the batteries and lines up the positive end. So this is the positive end, sorry. Positive end and negative end. So you're going to go, the positive end is going to connect to the negative end of the next battery. And so I've got little clips. No, don't do that. Sorry. Amateur videographer, sorry. Little do, you did great. So you want to clip the parts of the battery holders together. So it's like a snap. So this is a series. So when the batteries are in a row, that's a series. And so what I'm gonna do is, if you remember from 2.1, oh, I have a friend. Look up, oh, I have a friend that came back. So anyway, if you remember from 2.1, one battery registered to be about 100, and so it was about 120, 130, 140. It was around 100, it was between 120 and 150. And remember I told you we have just a little bit of variance because the connections aren't always that great, and sometimes the connections can be better or worse. And so if the connections are better, it'll be more close to 150, and then if they're not so great, it'll be closer to that 120. So remember too, the positive end of the battery goes to the positive end of the ammeter. And now I've got the ammeter. So I've got positive end going to the positive end, and the red is the positive, and then the black is the negative. So you may see your parents trying to jumpstart their cars with this. So now I'm going from the negative end to the light bulb, and then from the light bulb, I'm going to go to the switch. And then from the switch, I go back to the batteries, but now I'm going to the negative end of the battery. And remember, always when you are connecting everything, you want your switch to be open so you don't electrocute yourself. And remember from our reading, we're not using enough volts to electrocute ourselves, but it's always better to be safe than sorry, so we leave our switch open. So when I close the switch, it causes the metals to come intact, and then current can flow through our system. So the light bulb comes on, and now that we have 2 batteries instead of 1, our current that's going through is about 220 milliamperes. So in a series, we're showing 220 milliamperes. So again, if the batteries are in line, then we have a series circuit. So now I'm going to show you a parallel circuit. So now that I'm moving things, I need to open the switch so I don't electrocute myself, and then put the batteries in a parallel. So when the batteries are in parallel, they're stacked on top of each other. And so can you see the metal parts in here? So that metal of the top battery wants to be touching the metal of the bottom battery. And then sometimes these like to overlap the wrong way. So, okay, I got it now. All right, so, who did it? Okay, so this is a parallel type of setup for the batteries. So now I'm going to connect my switch is still open, so now I'm going to connect the positive end of the ammeter to the positive end of the batteries, which remember too, the positive end of the battery is where the little nodule is coming out. The negative end is the flat end. Okay, so the battery or the switch is open, the batteries are in parallel, and so now we're going to close our switch. And so closing our switch puts it back at 150 or 160, somewhere around there. So that difference between 150 and 160, so it was 150 with one battery, it's showing about 160 with the second battery. So remember, that small amount of difference in current is negligible. That's what we call it. We say that it's negligible because we're looking at milliamperes, and 1 milliampere is 1,000th of an ampere. So just 1,000th of an milliampere, or 100. Well, 10 milliamperes is actually 100th of an ampere. So that 100th of an ampere is not that big of a difference between one battery and 2 batteries. So again, this is your parallel setup for a circuit. And so let's go through the rest of the questions. So do you think batteries are connected? Do you think how batteries are connected affects current in electrical systems? So I actually went through all this with you. So what do you think now that we have compared? So I'll give you a second to write that down. If you need to pause it, you can, but you're answering, do you think how batteries are connected affects current in an electrical system? Why or why not? So answer that. And then, like I said, if you need to pause it, you can. So we're going to go to the next page. On number 3, it says the materials used in this investigation include 3 batteries and holders. So I only brought 2 home. I'm sorry, I should have brought 3. 3 alligator clip wires, 1 ammeter, 1 mini light bulb. So ammeter, mini light bulb, in its holder, one switch. So write one question that you think could be answered using these materials. So I went through several scenarios with you. We will discuss the questions that you think of as a class. Well, we can't do that on virtual, but we can do that on our Zoom call if y'all would like. We can talk about the questions that you had on Zoom, on the Zoom call. So some of the things that I thought of was, what are we measuring here? We're measuring current. So you have to think of a question that has to do with measuring current. Well, the things that I thought of is we only have one ammeter, so that measuring current is the only thing we have. We have one mini light bulb, one switch. So the only thing we can manipulate is the number of batteries or the way that the batteries are aligned. So either parallel or series. So make sure that you write down your question. Number 4 says to write down the question that we'll answer as a class. So just write down your question for number 4 again, because we can't do that as a class unless we have a Zoom call. Number 5 says make a prediction using the words if and then that address your prediction. So make sure you take your question that you have and make a prediction about that. So the question that I'm going to ask is, does the current increase or decrease if we have more batteries? So my prediction would be, if we add batteries, then the current will increase. And I'm going to keep it in a series setup for the circuit. Number 6 says to read Building Your Knowledge, Asking Questions and Controlling Variables on page 30 through 31 in the Lesson 2 book on CarolinaScienceOnline.com. And I'm going to read that to you. I'll do that later tonight and put it up on Schoology, because I know y'all like me reading that to you. So it will be on there tonight when I upload this, so you should already have that. And then listen to that as I read it to you, and then answer the number 6 question. It says, why is it important for scientists to plan investigations in which variables are controlled? So remember, a control is a variable that we keep constant. So keep that question in mind as you pause this video. Go to the video where I'm reading the reading selection for you, and then once you're finished, answer that question and then come back to this video. Number 7 has several questions that you've got to answer. So this is about how you will plan an investigation that will answer your question. Consider the following questions as you develop your plan. So again, my question was, does increasing the number of batteries in a series increase or decrease the current? So I'm going to go ahead and put this in a series. Okay. So mine's set up in a series. I've got 2 batteries. I'm going to start off with one just to remind us how much current is going through with just one battery. So our letter A in number 7 says, what variables do you need to consider? So variables to consider here is how many batteries that we have that we can manipulate, and then what would be the current. So the 2 variables that we have are the number of batteries, and then the dependent variable that we're measuring is the current. So our independent variable is the variable that the experimenter changes. So I'm the experimenter and I'm changing the number of batteries that are in the series circuit. The dependent variable is the variable we measure. And remember, if we have a graph, we put the dependent variable on the y-axis, and so that's the one we measure, and we're measuring, in this case, current, because this ammeter is the only tool that we have to measure anything. So make sure you answer number A. Letter B says, which variables could be kept constant? So materials used to connect components and the type of batteries used. So we need to keep constant the materials that we use to connect everything. So we're keeping our alligator clips constant. We're keeping the same type of clip between each component. We're also, I should have kept these batteries the same. In fact, that's what I'm going to do right now. I'm going to change this battery. So I don't need to have two batteries that are different. I need to have two batteries that are the same. So I changed that. So we're keeping the type of battery the same. So I've got the brand being the same, and we have the D cell batteries. So the D cell and the brand are going to be the same. So those are controls that we're keeping constant. Letter C says which variable will change as the independent variable to observe how it affects the other variable, which is the dependent variable. So the independent variable, again, is the one that I'm changing. The experimenter is changing. So I'm changing the number of batteries. And then again, the dependent variable is the variable we measure. And so we're going to measure it using the ammeter. That was letter C. So letter D says, what is the goal of your experiment? So the goal of my experiment that I decided to look at was to see if increasing the number of batteries increased the current. And remember, the batteries are changing chemical energy to electrical energy and putting the electrons through the current. Letter E says, how does your plan generate data related to your goal? So if I change the number of batteries and collect data on the current, so what I'm going to do is the data that I'm collecting is the current. Okay, so let's go to the next page, and I've created a graph for you. So I've created a graph for two different scenarios, and I put extra blanks in there in case your graph that you wanted to create is different. So I've got two different graphs. So the first graph is what I'm experimenting with. It's the number of batteries. So I've got one battery and two batteries. So I'm going to plot that data now, but then if you wanted to have a different type of experiment, we'll come back to this later, but you've got the type of circuit that you're changing. That's the independent variable, series or parallel, and then the current is what you're going to measure. So the question 8 says, use the table to create a data table you can use to record measurements during your investigation. Use one column of the data table for your independent variable. So my independent variable that I'm doing first is the number of batteries, and the other for the dependent variable. And remember, dependent is the one we measure, and current is the one that I'm measuring, and we're measuring it in milliamperes. And then we're going to record our data, or record the data in your data table as you work. So I need to figure out the current of one battery. So we did this in 2.1, but just to remind you, I'm connecting everything. My switch is open, and now I'm going to close it. And with one battery, it looks like it's 160 milliamperes. So I'm going to write that on my data table. So I'm going to write 160 milliamperes on my data table. And now I'm going to add a battery and see what the current is with two batteries. So I'm going to open the switch, add the battery with the positive and negative ends. So this is a series, and then connect it back. Now I'm going to close the switch again, and now my reading is at 230 milliamperes. So I'm going to plot or put my data down there. So 230 milliamperes for this experiment. So let's read the next set of questions. So how did the batteries affect the electric current during your investigation? So increasing the number of batteries, what does it do to current? Does it increase or decrease? So if you increase the number of batteries, what happened to current? Did it increase or decrease? So what was your prediction? What did you predict would happen? Write that down again. And then what claims can you make about how batteries affect current? So what evidence do we have that showed that as you increase the number of batteries, the current increases? So the evidence that we had was the readings on the ammeter. So the readings increased to 230 when we added a battery, and that increased to 230 from 160 milliamperes. Does does the data you collected provide evidence to support your claim? So what was your claim? What did you predict would happen? And then does the data where we wrote down 160 milliamperes for one battery and 230 milliamperes for two battery, does that data support the claim that you have? Why or why not is number 13. Number 14 says, if the data collected does not provide evidence to support your claim, what experiments must be performed to gather evidence necessary to support it? So that's going to depend on what your claim was. So you would need to formulate that answer on your own. And again, if you need to pause this for a second, you can, and then come back. So what scientific reasoning supports your claim? So I know scientific reasoning may be difficult to think about, but just for example, current increased when the number of batteries increased. So that would be scientific reasoning. So that's just talking about the evidence that you have and what happened in the experiment. Number 16 says, is there anything you would change about your investigation if you could do it all over again? So maybe if we added another battery, we could see what the current would be if there were 3 batteries instead of just 2. That's one suggestion I have, but maybe you can think of other suggestions too. 17 says, how do you use variables and controls as you planned your investigation and carried out your plan? So think about the variables. We needed to keep the types of batteries, the alligator clips, all controlled, keep those the same type. And then how did we change the independent variable? So we added more batteries. And then number 18 says, how could you use a mini light bulb to gather data during this investigation? So what do you think happened to the light bulb? So as current increased, what happened to the light bulb? Do you think it got brighter, or do you think it got more dim? How could you use that to determine how much current was going through? So if you answer that, that's good. I'm going to go through and do the experiment with series versus parallel. So again, we have our data table. So if I do series and parallel, I want to see what the current is for I'm going to use 2 batteries. The series battery with 2 batteries, remember it's 230 milliamperes, so I'm just going to take that data and put it here. And then parallel, so I've got my switch open, and then I'm going to take these and put them in parallel again. So I've got the positives lined up and the negatives lined up, and these aren't working right. Okay, there we go. All right, so again, this is parallel when they're stacked on top of each other. So I'm gonna hook these back up, and when I close the circuit, it's back at 150. So remember, 150 milliamps was what the current was with just one battery. So if I take this battery off, again, I'm just showing the one battery, and let's see what happens to the current. It stays about the same. So what we're showing here is that with a parallel type of circuit, 1 battery versus 2 batteries in parallel, it doesn't change the current. So you don't increase current when you have a parallel type of circuit with the batteries. So you can use that information and go through the questions again and answer those, or you can just stay with the experiment that we did together. I just wanted to show you that if you increase the number of batteries in parallel, it does not change the voltage. So again, I'll show you that again because that's a little tricky. So here's the current with 1 battery. Remember, 1 battery is about 140, 150. So I'm gonna open the circuit and then put these in parallel, put this back up, And again, when I close the circuit, it should be about 150. It's 160. And again, that 100th of an amp is not significant enough to be a big difference. So one battery versus two batteries in parallel, the current's gonna stay the same. So I hope you have enjoyed this. I miss you all already. Teddy says goodbye. Show Teddy. Teddy, you wanna speak? Speak. Speak again. Speak loud. Speak. Okay, that's good enough. Okay, well, Spike's speaking too. Anyway, I hope that you were able to get this. If you had questions, just email me, and we will have Zoom on Monday at 2 p.m. and I'll send out a remind and an email about that. But hope you're doing well, and I'll see you next time. Bye.